Okay, so we have this problem set. Okay, so your plant, which is this one, okay, um, it uses two air compressors, okay, or air compressor pumps to provide a fresh supply of air or compressed air into a 25-liter tank. The tank has a pressure switch that activates once the pressure goes below 15 psi. Okay. So, uh, okay. For which one of the pumps should work to shore up the pressure? Okay. So, the job is to create a PLC program that does this action of managing the two pumps. Managing the two pumps. Okay. So, ito yung requirement natin. Okay. So, let's proceed. Okay. So, we'll create a new project. Let's use the documents. Okay. And we'll go to folder. Dual pump example. Select folder. So again, the language that we're using is LD. Okay. So again, we always go back to the basics. How do we turn on and turn off the pump? So basically, we're using a relay, whether it's a contactor or a simple 12-volt relay system that can work with high amperage pumps. It's really up to to the mechanical aspect of it. Typically, in a job site, these things are already installed. They're not, well, you have to consult with your mechanical engineer and your electrical engineer on site because you have to understand how much electricity is drawn by a particular mechanical action. Okay. So that being the case for this one, okay. So let's proceed to assign some values for us. Okay. So we'll start with the pressure switch. Okay. So the pressure switch that we understand here is once it reaches a below 15 psi rating, it should trigger. Okay. Now, typically a pressure switch has a low and a high uh, potential value. Okay. So we're looking at two switches. So this one is the 15 psi switch. And we should have an upper limit one as well. Okay. Let's say the value for this one is uh 40 psi. Okay. So it's still a Boolean value. It's another pressure switch. Again, when you are working with pneumatic or equipment which uses high pressure, you basically need a kill switch. Okay, you need a start and stop switch. So here, we need to include a kill switch, which is basically a stop switch. So we should have two sides to the story. The first one is a stop switch, which is normally closed. Okay. And this is assigned as an input. And then we have also part of this one connected to the other side, which is the uh, mechanism to power the compressor so that we can remove the input power towards the compressor if need be. So this one is just for the monitoring side if the switch is actually pressed or not. Okay. So the other one is the start switch. Which is normally open. Again, locations, we are going to put these two into the first two because they are actually the interrupt pins for the processor. Percent I X 0 at 1, percent I X 0 at 2, and percent I X 0 at 3. Okay. So these are our sensors. Sensor for activation. Sensor for stopping motor action. Emergency stop. Emergency start. Okay. So we'll not put any initial value into it so that we don't really mess up the operation of the PLC. Okay. So now comes the output side. Okay. So we should have two relays. Relay one, which is again percent Q X 0, which is D7 motor relay coil compressor 1. Okay. We add another one, just copies it. So we just change this one to this value. Again, here we assign a value since we do not want the relay to be prematurely activated. So if your relay is activated by 5 volts, you need to place in 1 if you want to activate it, or 0 if you want it to be deactivated. So in this case, I'm assuming that that will be the case, but in the laboratory setting, we all know that the relays that we're using are actually the other side. They're inverted. So they're activated by 0, they're deactivated by 1. So we just make sure that those two relays are actually deactivated. Okay. So let's move on. Okay. So in this case, we'll just be looking at the operations for each of the following items. Okay, yung NCNO natin. Okay. So a perfect way to do that would be to assign a particular rung separate from the others, covering NO and NC put together. Okay. So here we'll place in a internal relay, RL1, and we'll remove the location. Kasi again, this is a internal relay and there should be no value. So we'll say internal relay 1, and then we'll prime it internal relay 2. So why am I doing the internal relay 1 and internal relay 2? Because sometimes we use a start switch which is normally open. When you press it, it closes, but it kind of pops up back to a closed, to an open position. Okay, so if that would be the case, then we would have a normal start switch, a negated stop switch, dito sa isang side. Tapos, we would have another one going into the other side. So once you have this pair set up, you now have to align it with the other one. So dito, meron tayong relay 1 na i-assign o internal relay 1. Now, the function of the internal relay 1 is to prime a specific value here, which is the start switch natin. So that the relay 1 can constantly be energized. Okay, so mali. Should be a switch. Hindi dapat ito yung action natin. Hindi. Normal lang siya. Tapos this one, we have to adjust it to 2. Yan, isa. Oops, sorry. Isa, dalawa. So you now have two switches that basically are in parallel with each other. Okay, let's see kung ano yung behavior niya. So we run it with using the start switch, the stop switch, and relay 1. Okay, so we connect this one, toggle ko. You see relay 1 goes to 2. Papatayin ko tong isa. I'll kill this one and relay 1 to 2. So it will only stop when you press the stop button. When it should stop when you press the stop button. But somehow here it doesn't. Okay. So it's kind of primed. Let's see why. Nandun lang naman siya. So shouldn't be an issue there. Okay. So I'm guessing this is an issue with OpenPLC. Okay. So another way to go about having a uh, resolution to this problem is to do it this way. Okay. Double click, let's put it to 3. Let's sever the ties for this one. And let's use a SR filter. Or an SR latch. And let's use a OR. So under bitwise operations, there's the OR. Okay. So this one will come here on this end. And this one should come here on this end. Well, technically that should work, but in all fairness, it doesn't. Okay, it's not really working out for any of us, okay, when it comes to that side. And then we have this one, which is the radio. And then we have this reset thing there. Okay. So let's try it once more. Okay. First obvious thing, we need to put this back to the normal setting. Okay, 2. One kasi siya gawa ng ano. Okay. I keep forgetting. I set that one up earlier. I actually forgot about it. Okay. So this should be reset and this should be set. Pabaliktad siya. Technically, pabaliktad siya dapat. Okay. For this one, we have to make sure that we have the dominant one, which is the set dominates, not reset dominates. Okay. So let's try it out once more. So when I plus this one, I toggle the value, goes to true. This in turn should be able to reset the relay. Okay. Hmm. Relay 1 doesn't, internal relay 1 doesn't want to change value. How come? I am suspecting that my OpenPLC is done for. Okay. So let's do a rehash for this one. Well, it should work, but it doesn't. Okay, so let's try it out once more. Sometimes the way that the simulator works for this one, well, it doesn't really do much justice when it comes to the outputs. Okay, so RL is false, R2 is false. Okay, so now we're in business. Okay, if I click this one to 2, RL becomes equal to, if I flick this one to false, that one also goes to false. Okay. So as you can see here, well, RL doesn't have any association with it. Okay. False pa rin siya. So, start switch to, this should be in a false condition. Okay. Stop ko. Hmm, sorry. Long, long, long. Let's put it back towards the normal behavior. It's a lot more easier to figure out. Okay. Start, toggle, 2. If I remove this one, false is still 2. Okay. Because the RL line here is feeding the OR gate and this is feeding the SR. So if we apply a switch to 2, we should be able to see a reset function happening. Kasi so dominated. Okay. So RS, the other one. Stop, connect, start, toggle, toggle. So it's still 2, toggle. Okay. So that's better na. Okay. So this is our stop switch. Okay, and start switch. So RL is now the prime uh, item that we will use for the rest of the implementation. So here we'll assign 5 rails on the other side. Copy, paste, 5 rails down on the other side. Right rail. Okay. So now we have the body of the program. So this is just the starter mechanism that we settled. This one is now the body of the system. Okay. So what we need out of this one is the ability to move in between the compressor pumps because the both compressor pumps should not be on at the same time. Well, unless you really want them to turn on at the same time. For that, you might need to add a emergency switch in order to boost the working conditions of the unit itself. Okay, to allow them to work or to shift or to operate both at the same time. Okay, so we'll include one more. Okay, boost switch, which is in the fourth or the last input terminal that we have. Okay, so here we'll do another item. Okay, we need to place in the input of RL1, which is the uh, connection to the start stop switches, and we basically connect or place a structure for each of the rungs. So meaning to say all of the rungs are actually actuated by this action that we have here. Okay. So next, okay, we need now to consider having a value of okay, pressure switch, PSI, uh, negated, okay, meaning to say uh, there's no value there. And the pressure is below 15 and the pressure is also below 40. Okay. So if this would be the case, we would need to start one of the motors. So in order to facilitate this one, we add in the internal relay 2 into the mix. So this causes us to force start the motors. Now, here lies the problem. If we want to to use two individual motors depending on the elapsed time, okay, that we have, we need to be able to activate them one at a time. Okay. So here comes the issue. The issue is there should be another power rail, light power rail, having two specific uh, outputs. One relay to activate the uh, one particular motor and the other to activate the other particular motor. Okay. For a boost period of a fixed amount of time. Okay. So for this one, we'll have a timing block. Okay. So TP is what we commonly use for this action. Okay. So we have two timers for two motors, and then we'll have additional two relays. So we'll need to add two more internal relays, internal relay 3 and internal relay 4. So 3 is for motor 1, 4 is for motor 2. Okay. So we'll add in RL3 and we'll add in RL4. Okay. So we need to put in some value here. Again, since we are working with time, we'll use T hash. Okay. I'll use 5 seconds to make it faster for the sake of the discussion process. Okay. So this would be this one. And we will move to RLs in between. Okay. So as long as the switch system is turned on, the pumps would actually be able to turn on and off. So the timing mechanism actually should work any which way that we have a operation here. So we'll use two rails. And then we'll have to force a uh, reset when RL becomes equal to RL4 becomes equal to negated 1. So let's save and test. Okay. So as you can see here, I added something, but it's not coming up here. So we'll save the system, we'll close the project, we'll reload the project. Okay. There, we already have the values there. So start, stop, relay 1, relay 2, relay 3, relay 4. So we just want to see if they are actually operating within the specifications. So do remember, relay 1 and relay 2 are pulses. So as you can see here, the other one is resetting, the other one is not resetting. Okay. So we should have here an additional input, which is basically RL3. This forces timer pulse 1 to only operate after having received the signal from the other timing pulse. So negated. Let's see how this fares. Okay. So no action there. Okay. So you can see they're actually synchronized with each other. Okay. So on here, on this end, we're left with the other RL statements and the other pressure switch statements. So we'd just say here RL2 and RL2. Okay. The birds are chirping outside. RL3, RL4. Yep. Okay. 1, 2, 1, 3. Okay. And then we'll put the motor pumps that we have. Relay 1, again, this is negated. And we'll have relay 2, which is also negated. Since our relay inputs are actually on the other side. Okay. So at this point, the 15 psi pressure switch and the 40 psi pressure switch are both false. So when I start the system out, you should see that, oops, sorry, I didn't start it. Okay. So they're just alternating. Okay. So one motor is turned on for a fraction of the time. So let's say that the 15 psi switch opens up. True na siya. Okay, you can see that we have a problem. They should be both one in order to stop the pump. Okay. So in this case, medyo problema siya. Okay. So here lies the SR treatment for this one. Okay. So we can remove this one. We can add an SR block. Set reset dominated block. So if both are low, we have a set condition. Okay. But once our switch, our 40 psi switch is high, so 40 psi switch is normal, and our 60 psi switch is also normal. We should get a different response from the system. Siya. So let's try it out again. Switch on ko. So it's pumping gas into the system. We reach the 15 psi point. So we still have both relays set. And then we reach the value of 40 psi for both. So now they're just basically all two. So again, RL3 and RL4 are free running. Okay. So as long as RL2 is false, it doesn't matter here. Dito sa kabilang side. So when this falls down and becomes equal to false, wala pa rin nangyayari. The pumps don't activate. But once this goes down, we now see the one of the pumps actually turn on. So they're just circulating between each of them. So if we set this one to something like 120 seconds or 2 minutes, we will just have a constant input to the system. So start, toggle, two. So we only have relay one as working. We need 2 minutes in order to facilitate the transfer to motor two, if that would be the case. So let's say we have a toggle up value for the first pressure switch. It's achieved, it's still on. Okay. So for the second pressure switch, it's still on. Out, out. Okay. We should have a value going up there. So let's wait for 2 minutes for the motors to change over. Okay, you see the motors change over to the other side. So again, go up. Doesn't do anything. Go up, it stops everything. Okay. So again, this is an example of how to do that one. Okay. So for this one, we need to add lastly the booster switch. Okay. So in any event that you have, you should have a booster switch set that will allow both relays to actually operate. You need an additional set of inputs here. Okay. So unfortunately, we'll have to add one more rung here. In doing so, we detach the uh, items away from the other one. Okay. So here, we'll have to attach another set of inputs. So those inputs are in particular RL and the boost switch. So boost switch. That's one. Boost switch. That's the other. So we'll save, we'll test it out once more. Now we need to add in the boost switch. So let's turn this on. And let's turn this one on. So here you see both of them. And technically, both of them should work properly. Okay. So apparently, I connected it incorrectly. It should be connected towards the end of the relay here to bypass the control structures for RL3 and RL2 altogether. So it doesn't matter if the pressure is lower or higher. If you press the boost switch, you get a okay. If the system is not on, you press the boost switch, nothing happens. But if the system is on and you press the boost switch, both motors are actually activated. So when you release it, it goes back to the normal set of conditions wherein only one is actually operated. Toggle, toggle. So in order to make it safer, so that you don't over pressurize the system, it would be better if you would could add an additional structure in between the boost switches, which is RL2. RL2. Mm. Sorry, that's the wrong key. Yan. Start, toggle value, okay. Press the boost switch. Both of them turn on. If one of these is true already, the other is also true, both motors actually stop. Okay. So that's about it for this one. Okay. So that's how you create a program from ladder diagram that does the operation of managing two pumps, alternating between each of the two pumps. So if you're going to say use one of the motors for uh 2 hours, okay, you'll change this one to 7,200 seconds. It's 2 hours. You change this one to 7,200 seconds. That's 2 hours. So there's a 2 hour difference in between the two of them. Okay. So do take note, RL1, the mechanisms for the internal relay 3 and 4 don't really operate when you don't have the on and off switch set. Okay. So there's no activity happening there. The system has to be primed in order for them to start operating. Okay. So that's about it for this one. Thank you for watching.